Alrighty, hello and welcome back to another week of science. This week we are learning about our fourth sphere of the Earth called the biosphere. Now we've already learned a lot about the biosphere, and you already know that the biosphere is all of the living things on Earth. So at the beginning of the year we spent a lot of time talking about plant life cycles, animal life cycles, and all of that has to do with the biosphere. So here's some gorgeous pictures of things that are in our biosphere, all the trees, all the flowers, all the fruits and vegetables, even all the plants underwater. And then, of course, all of the animals on Earth. And here's just a smattering of my favorites. Gorgeous. So what are the four spheres, that should say, sorry for that typo. Here we go. We've got the geosphere, hydrosphere, atmosphere, and the biosphere. So at this point, we're all pretty much experts on these spheres. We've spent a lot of time talking about all four of these. And my next question is, what do the prefixes mean? So you guys know that I love to spend a lot of time learning about the prefixes and roots of words because that makes us better at the English language, right? When we know lots of prefixes and we know roots and the meanings of roots, we are better able to figure out the meanings of words that we're unfamiliar with, right? Words that we don't know. We can sort of figure out what they mean based on their little parts and pieces. So here are a couple important prefixes for us to know in science. Geo, which is grounds, rocks, dirt, or sometimes it means shape or form, right? So that has to do with the land forms on Earth. Hydro, which is water. Are you hydrated today? Are you well hydrated? Atmos, which is what we learned last year. The atmosphere is all the air or the gases around our planet. And then bio. What does bio mean? That is your first question on your Google form. So go ahead and pause your video and answer question number 1. What does the prefix bio mean? What does bio mean? Okay, and you guys are old pros at this. You know that when you're ready, you press play. And bio means life. Bio means life. Awesome. So what is the biosphere? The biosphere is all the living things on Earth. That includes plants, animals, and we already know that the animal kingdom can be split into 2 parts, right? Vertebrates and invertebrates. So vertebrates would be all of the mammals, birds, reptiles, fish, amphibians on Earth. Most of our favorite animals, right, are vertebrates. And then you have all the invertebrates, and invertebrates actually make up more of the animal kingdom, right? The majority of the animal kingdom, up to 97% of the animal kingdom, is invertebrates, right? And that would be insects and jellyfish and mollusks and snails, right? All of the different creatures that we've learned about, starfish, all of those invertebrates that make up our planet. Okay, and then we also have fungi, which are like mushrooms, and bacteria. So these are categories of living things on Earth. Oh, and just a quick reminder, a couple of weeks ago, right before spring break, we had been talking about viruses, and we went over the scientific debate over whether viruses count as living things or not. And during that class, which was March 19th and March 20th, during those classes we discovered viruses are not living things. So even though bacteria and fungi count as living things, a virus does not. A virus is a little bit different. And that's because it doesn't fit into all of the necessary qualities or characteristics that living things share. So let's go over what those qualities and characteristics are. Okay, so living versus non-living. How do we categorize things? Sometimes it's hard to tell if something is living or non-living, right? If something is a part of the biosphere or not. For example, let's think about clouds. Are clouds alive? Right? They move and they change shape. What about the wind? Right? You can feel it, you can hear it. Kind of seems to have a life and energy of its own. Same with your computer or your technological devices, right? Your computer gets warm, it makes sound, it listens to you and responds to you. And what about, Siri or Alexa or Google Home or, any of these like artificially intelligent devices or quote unquote personalities that we have in our home, right? Do these things count as living things? Or your television, right? There's all sorts of things in our life which might seem to be alive or seem to have some kind of life of their own. But when we talk about living or non-living things, we are trying to look at it from a scientific perspective, right? So how do scientists classify living things? And scientists look at a list of 7 specific features to see if, or features or attributes, right, or qualities, to see if something can count as a living thing or not. Okay, so when a scientist is trying to determine is this a living or a non-living thing, they ask these 7 questions. First, does it move? Can it move on its own? Second, does it respirate? Right? And respirate means does it breathe? Does it take in gas from the atmosphere and put gas back out into the atmosphere? Does it respond to stimuli? Right? So will it react if it is in danger, or will it, hide or shrink from pain? Does it get excited by loud sounds? That kind of thing. Does it react to its environment? Okay, so that is the beginning part of Mrs. Gren, MRS. Does it move? Does it respirate? And does it respond to stimuli? Okay, so most of us, especially 4th graders, are familiar with Mrs. Gren. That's the acronym that we're using right now to remember all 7 of these questions. Right, so the very first part are these 3 questions, MRS, which you'll see spells Mrs. Okay. Oh, and then another way to say stimuli. So this S in the Mrs. could stand for stimuli. Does it respond to stimuli? Or it could stand for sensitive or sensitivity. Right? Is it sensitive to its environment? Does it react to pain and danger and hot and cold? Okay. All right, and then the second half of these questions spells out G-R-E-N, Gren. So the scientist asks, does it grow? Does it reproduce? Does it eliminate waste? And does it need nutrients? Right, so some of these are pretty self-explanatory and some of them are not. Does it grow means can it grow on its own? Does it add mass to itself throughout its life? All right, that one's pretty obvious. Does it reproduce? Reproduction means making copies or making babies, right? So can it make more of itself? Can it make more of its own species? And then these last ones, eliminate waste, basically means does it poop and does it pee? Or another way to think of it is does it shed extra nutrients and minerals and vitamins, things that it doesn't need, right? So not only do we eliminate waste through peeing and pooping, but also through sweating, through exhaling, right? Even just breathing out into the atmosphere is eliminating some toxins from our body. And then finally, does it need nutrients? So living things get their nutrients in different ways. As animals, right, we're consumers. So we have to eat to get our nutrients. And you know that plants are producers. So plants do photosynthesis to get their nutrients, right? So all living things get their nutrients in slightly different ways, but they all have in common that they need some kind of nutrients, some kind of energy to keep them going, right? So these last 4 questions spell out GREN, G-R-E-N. Does it G for grow, R for reproduce, E for eliminate waste, and N for nutrients? Okay, and another way to say E, this E word right here, eliminate waste, right? Eliminate means to get rid of. So get rid of waste. Or another way to say that E word is excrete. Excrete. Excretion is pooping, right? It's the same as getting rid of waste. It means the same. Okay, so all living things have to fall into these categories. Mrs. Gren, M-R-S-G-R-E-N. All living things need these 7 characteristics or qualities in order to count as a living thing, at least by scientific standards. So viruses cannot do all these things. We've talked about this before. That's why viruses don't count as living things, right? A virus is not a part of our biosphere because everything in the biosphere has to do these things. It has to move, has to breathe, has to respond to its environment, has to grow, make babies, eliminate waste, and it needs nutrients. Okay, so all living things have Mrs. Gren, right? And Mrs. Gren is just the acronym that we use, right? It's just a way to remember those 7 characteristics or these 7 letters, right? So Mrs. Gren is not a real person, just a way to help us remember. All right, so go ahead and pause your video. We're on question number 2. Tell me, what do all living things have in common? And if you have to rewind and go back and rewatch a section, go for it. Okay, beautiful. So hopefully you wrote something along the lines of these 7 things: movement, respiration, sensitivity, growth, reproduction, excretion, and nutrition. Those are the things. Okay, so of course, animals do all of these things. And with animals like humans, I think it's pretty obvious. It's really easy to see the way that we fit into these categories, right? You do all of these things easily. You move, you can move your arms around, you're breathing right now, you're sensitive to your environment, right? If it was really hot, you might want to take off a layer, or you would pull your hand away from a hot stove, or vice versa. If it was cold, you would be shivering, right, and getting goosebumps. And then also you can tell you grow, right? Your hair is growing, your nails are growing, your body's growing every day. We as humans can reproduce, right? That's how you were born. Your parents have babies. My parents had me, right? That's reproduction. And then we poop and pee and eat all day, every day. So these things are really obvious and really easy to notice inside of animals, especially humans. Right, so here is just a short clip. I wonder if it will play for us. Perfect. Of humans being part of our biosphere. it really would be a lot more fun to watch without all the buffering. So I will go ahead and post a link to this video inside your Google Classroom. I'll go ahead and post a link to all the videos that are in this slideshow, just because I don't want to take a bunch of time just to watch it buffer. But what this video is showing you, the reason I included this video in today's lesson is because I just want you to see the wide variety of human existence, right? It's just a quick preview, just a quick snapshot of all of the ways that humans are interacting with our Earth all the time, all around our planet. We are a really essential and huge part of the biosphere and of our entire planet. So I really like this clip. I'll post a link to it in your classroom so that you can watch the whole thing. Okay? All right, so I want you to pause the video and go to question number 3 on your Google form. Tell me, what makes you feel the most alive? What makes you feel the most alive? For me, what makes me feel the most alive is when I am in awe or when I'm a little bit afraid, when I'm trying something new. So if I am maybe rock climbing on a steep cliff and I'm pushing really hard and I'm not sure if I'm going to be able to do it, and I'm a little bit afraid, but I'm also really excited and really in awe of the beauty around me, that's a moment where I feel really alive. Or, when I make it to the top of a mountain, or sometimes even just driving in my car, watching the sunrise or watching the sunset, feeling the wind blow past me. All of these things make me feel alive and grateful to be alive. So it's really obvious that humans are living things. It's obvious to us. And I also think it's obvious to see how animals are living things. But sometimes it's hard to see how plants and bacteria and fungi fit into all of these categories of MRSGREN. So let's see. Let me give you some examples of how plants and fungi and bacteria are fitting into these categories. Okay, so M stands for move. And I have quite a few YouTube videos embedded in today's lesson, so let's hope that these load for us and we're not spending the whole time buffering. If the lag is too great, then I will simply link these videos in your daily agenda or in your Google Classroom. That way you can go and click and watch them. Okay? So here's an example of plants moving towards the sun. So if you were just watching this tiny little plant, you might not be noticing it moving, but we're able to see these plants moving right now because it's a time lapse, right? So that was a very sped up video showing one whole day in a matter of seconds. So when you speed up the video, then you can see how the plants are actually moving, right? Those plants were reaching towards the sun and gradually leaning one direction. So plants do this all the time. Here's another quick shot of it. Plants are doing this all the time, and sometimes it's easier to notice in some plants than others, but they are moving gently, right? A plant is able to move to follow where the sunlight is and to direct itself to gain the most amount of energy possible. So here are some seeds that have just germinated and are sprouting, and you can see them sort of leaning towards the light. Close this advertisement. So as you can see where the sun is. And once they move the light source over to the other side, then the plants start leaning in that direction. Okay, so you can watch them moving back and forth. Pretty cool. Pretty cool. Okay, go ahead and pause your video and let's go answer question number 4, which is, why do plants move? Why do plants move? Okay, and the answer is because they're following the sun. They're trying to get as much sunlight as possible. Okay, so M in Mrs. Gren is for movement. R stands for respirate. And what is respiration? Right? Respirate just means to exchange gases. So another way to say it is just breathing. Let's watch this quick video on respiration in living things. So the title of the video is, Do Plants Breathe?
So plants can make their own food, which is a pretty big deal. But the flip side to photosynthesis is cellular respiration, the grand old process of breaking things down, aka eating the food. Both animals and plants do it, and thank goodness we all do, because it's one way we keep the system in balance. While only plants are involved in photosynthesis, both plants and animals perform cellular respiration. And unlike photosynthesis, it doesn't require sunlight. On one side, photosynthesis takes in energy from the sun and carbon dioxide from the atmosphere,
and water.
It builds up and stores food and releases oxygen. On the other side, cellular respiration uses up that food and oxygen and releases energy into the cell and eventually the environment, and you may have guessed it, produces carbon dioxide in the process. Yin, yang.
Okay, so this balanced process of photosynthesis and cellular respiration is showing you how all living things respirate. And all that means is that they take in gas from the atmosphere and they release gas back into the atmosphere. Now we, as humans and most animals, take in oxygen from the atmosphere. So when I'm inhaling, I'm taking in oxygen, and when I'm exhaling, I'm releasing carbon dioxide and some water vapor, right? And a little bit of oxygen too. And then plants do the reverse. So plants are taking in that carbon dioxide and they're breathing out oxygen, right? And plants and bacteria and fungi, they don't have lungs, so we might not think of it as really breathing, but we still count it as respiration as long as they're taking in gas and releasing gas. So all living things do this. Okay, so pause your video and tell me, what is respiration? What's respiration? Alrighty, and you could have told me respiration is breathing, or you could say respiration is the exchange of gas. Exchange of gas, so a trade. Exchange means trade, right? So I'm trading gas, giving carbon dioxide out, taking oxygen in, or vice versa for a plant. Okay. Oh, did we miss G for grow? Oh no, S. We're on S. So M for move, R for respirate, S for respond to stimuli, or another way to say it, sensitivity, right? That just means sensitivity to your environment. So it's easy to understand how animals are sensitive to their environment. Remember, we've talked about the example with the squirrel and the rock, right? If you throw a squirrel into a pond or into a fire, right, he's going to freak out and run away and try to get out of there. Whereas if you throw a rock into a pond or into a fire, it's not going to respond to that stimulus, right? It's not going to react because it is non-living. So it doesn't have any sensitivity to its environment. Okay, so animals obviously react to their environment, and here is a quick example of a plant, a very sensitive plant reacting to its environment. In fact, this type of plant is actually called or nicknamed the sensitive plant. Let's watch. Oh, they went backwards. Let's try again. There we go.
Hey YouTube, I found an interesting plant at the Auckland Domain Winter Gardens. This plant is called the Mimosa pudica. This plant is very unusual because it can fold up its leaves when they're disturbed. Although many plants can move and fold according to weather and light conditions, this plant moves very rapidly. It accomplishes this by changing the amount of fluid pressure inside some of its cells. These cells on one side of the leaf stem will lose their fluid pressure, causing the leaf to fold in that direction. Although it is native to South America, the Mimosa pudica can be found.
Okay, cool. So that is just a quick example of a plant reacting to its environment, right? Closing up its leaves as soon as it got touched. And here is a brief video of some bacteria responding to their environment. So this big black lump that you see in the middle of the video is actually a grain of sugar. It's a sugar crystal. And let's see all these tiny bacteria react to the presence of sugar. So notice what happens in their bodies. Okay, well there was quite a bit of lag on that video, but you might have noticed that the bacteria is responding, let's try again, that the bacteria is responding to that sugar crystal by vibrating, right? Their bodies start to shake and shiver pretty drastically, okay, as they surround the sugar crystal. It's a really short video, so let's just see if we can watch it one more time without lag. But now notice how they're starting, as soon as they get into the proximity of the sugar, their little bodies start vibrating. So this is a reaction. It's a reaction to stimulus and a response to their environment, right? Like all living things have. Sweet. And then we know all living things grow. It's really easy to see how animals and humans grow. It's easy to see how plants grow. Maybe you've never thought about fungi or bacteria growing. So let's quickly watch some fungi growing. Here are fungi or mushrooms that are, again, this is a time lapse, so we're seeing footage that is really sped up, but I think it's a really fun way to watch things growing, right? This might take days or weeks for these mushrooms to grow this way, but it's cool that we get to see it in just seconds. And remember, these are all living things. So we could maybe talk about, you know, whether all living things have conscious thought. You know, do all living things have feelings? Do they all have dreams? Do they all have a mind? You know, those are questions that we just don't know. You know, we could, we might have ideas, but we just don't know. But we do know that these living things follow the 7 requirements of Mrs. Gren. Right? So again, I'll post a link to this video so that we can watch the whole thing. But I don't want to take too much time during the lesson video since this has already gone for 30 minutes. So let's see if we can move on. That's just a quick snapshot of some mushrooms growing, fungi growing. Okay, and now we're on to reproduce. So all living things reproduce. And again, it's easy to tell with animals and humans because obviously we see them making babies, right? We've seen human babies, and we've seen puppies and kittens and baby goats and baby chicks and all sorts of baby animals, right? So we know about animal reproduction. And we've talked about plant reproduction as well. We know that plants make seeds from pollination, or sometimes they make spores in order to make babies. But here is one quick video to show you what bacteria looks like when bacteria is reproducing. So bacteria are just single-celled organisms. That means they just have one cell in their entire body, whereas humans and animals have billions, trillions of cells, right, in their bodies. Each one of these tiny little pill-like looking things, these little worm-looking things, each one of these is a bacteria or a bacterium. And as you can see, each one is growing and then splitting itself in half. So it's creating all these different copies of itself, right? So we went from, I think in the beginning of the video, there were maybe 4 or 6 bacteria. And now, after 3 hours, you can see that they've multiplied and reproduced drastically, right? Their numbers have increased exponentially. So this is germs, baby. This is how germs work. They are constantly reproducing, like all living things, okay? All right, so pause your video and answer question number 6 for me. What does reproduce mean? All right, and now we're on to our last 2, excrete, which means to get rid of waste. So let's watch Dr. Binox tell us a little bit about it.
Oh, who's that?
Hey! It's disturbing the air around us. Sorry. Hey, I know I'm farting a lot today. Oops. Guess you took in a lot of carbon dioxide for lunch yesterday. Oh, yeah, could be.
Okay, so this video is excellent, but I'm going to go ahead and just link it for you in the Google Classroom, just because it's buffering and lagging a little bit, so I don't want you to sit and watch the lag. But basically, this video is showing you that all living things have to get rid of extra waste, right? As you heard just in that very first beginning clip, the rose flower was saying, oh, guess you took in too much carbon dioxide. Right? And all living things do this. If we take in a little bit too much of something, whether that is water or vitamins or minerals or a certain type of nutrient, if we have a little bit of excess, then we have to get rid of it somehow, right? And that's either through pooping or peeing or sweating it out. And even plants and fungi and bacteria do this too, by just releasing their excess waste into the air or back into the ground. Okay, so pause the video. I believe this is your last question, number 7. It's not quite the last question. There's one more after this. But second to last question, how do plants excrete waste? Okay, and then the last requirement of living things is that they need nutrients to survive. And again, this one might be pretty obvious because we have to eat or we'll starve to death. Same with animals. Same with plants, right? Plants have to get nutrients in the soil, and they have to have sunlight and water. And you know, if you don't water your plant or you don't give it enough sunlight, it's going to die. So same with all living things. So here's a quick example of fungi, where fungi gets its nutrients from. Let's see if we can watch this without lag. But what this video is going to show us is some slime mold, which is a fungus.
Meet the
Let's see
slime
what it eats. What does it, where does it get its nutrients from? And again, this is a living thing, right?
For much
This
of
is
the year,
alive.
they live as single cells, but in autumn, they come
Oh boy.
together. A relentless, shape-shifting yellow goo that scours the forest for bacterial food.
So it was
The
lagging
slime
a
mold
tiny
eats
bit.
anything that gets in its path, devouring mulch and decaying matter. This blob provides an essential service in cleaning up our woodland.
Okay, so again, I'll link this video for you, but basically what it's showing us is that slime mold, as it goes throughout the forest, is living off the nutrients of bacteria and decomposing matter, right? So it's not eating fresh fruits and vegetables, but the mold is actually living off of dead stuff, off of decaying matter, and off of other bacteria as well. Okay, so your final question on your Google slide form, go ahead and pause the video and go to question 8. What does slime mold consume for nutrients? And a lot of fungi, not just slime mold, but a lot of fungi will live off of decomposing or decaying matter. That's where it's getting a lot of its nutrients from. Okay. So to recap, what did we learn today? Today we learned what is the biosphere. We know bio means life, and so the biosphere is all of the living things on Earth. And we asked ourselves, what makes a living thing, right? It's anything that follows Mrs. Gretton. Anything that moves, breathes, responds to stimulus, grows, reproduces, eliminates waste, and needs nutrients. All 7 of those things, and that makes it a living thing. So our categories of living things in the biosphere are plants, animals, fungi, and bacteria. Alrighty, so later this week we're going to review plant life cycles, animal life cycles, and talk a little bit about different biomes on Earth. And then on Friday we will take our 4 spheres test, our unit test on all of the 4 spheres. So we have learned a lot so far, and now it is time for your DOL. If you have any questions, let me know, and I will talk to you later.